Hello everybody. I welcome you all in 16th session of your physics paper 1 syllabus. In this session, we are going to speak something about the loudspeakers. Our main focus is on moving coil type loudspeaker. So a loudspeaker is nothing but a transducer that converts input signals, obviously of audio frequency, to the sound signal of same frequency. There are various people who have contributed to the design and construction of loudspeaker, but basically the idea of electronic loudspeaker was first developed by John Williams in 1861, and there was then a queue of scientists who have worked on the loudspeaker and have developed various new versions of loudspeakers. There are various ways by which we can classify loudspeaker into different categories. Let us now first look upon the loudspeaker types, where these types are classified depending on the range of sound they reproduce. For example, the loudspeakers could be full range loudspeaker, mid range loudspeaker, tweeter or woofer loudspeaker. How they have classified in this way? Depending on the range of sound, the frequency range of sound measured in hertz, which will be reproduced by that particular speaker. An ideal loudspeaker that can reproduce almost all audible frequency range as possible is known as the full range loudspeaker, whereas the mid range loudspeaker is the loudspeaker which can reproduce sound in the frequency range of 250 to 200 2000 hertz. These are known as the mid range loudspeaker. Tweeters, the name given by the tweet of a bird, because birds produce quite higher pitch sound as compared to the human being. The pitch of the sound of bird is larger, that is frequency is larger in case of birds as compared to human being. So tweeters are nothing but the loudspeakers that are designed to produce high audio frequencies, whereas woofers, in opposite to the tweeters, there are woofers, or what we can say usually it as the bass speaker, which is a loudspeaker that is designed to produce a low frequency sound, typically of the range of 50 Hz to 1000 Hz. There are also the woofers that works on extremely low frequency range, what we call it as the subwoofers. So this picture I always I have seen in many programs, but now I got the point what is the meaning of these different circles here. These are nothing but the mid-range loudspeaker, tweeter and woofer. For example, these two are nothing but the woofers that reproduce sound of low frequency. The small one is the tweeter that can reproduce sound of very high frequency, and mid-range loudspeaker, this one is responsible for the reproduction of sound in the medium audible range. So in this way we can classify a loudspeaker into mid-range, tweeter, woofer or full range loudspeaker depending on the frequency range that can be reproduced by that particular loudspeaker. Now loudspeakers are also classified based on its design. Based on the design, a loudspeaker could be of cone type, it could be horn type, or it could be a dome type loudspeaker. Let us see one by one. So this cone type loudspeaker, which is very familiar when we see some historical gramophone, etc. So this cone type of loudspeaker consists of a cone which is made up of paper or plastic or polypropylene, a very light material from which this cone is made up of. In this case, in cone type of loudspeaker, the energy that will be given or supplied to this system is directly transferred to air through this cone. And as a result of this, these cone type loudspeakers are also known as the direct radiators. As it is directly passing this mechanical energy to the air, for which the impedance is very low. Here we are speaking about the acoustic impedance. Acoustic impedance, which is a term that depends on the pressure. So pressure is high, impedance will be high. Pressure is low, impedance will be low. So in this case of cone type of loudspeaker, the impedance of this cone system and the air that doesn't match at the boundary. As a result of this, there is a great mismatch of impedance at this boundary. As a result, the efficiency of these drivers or loudspeakers is very small, of the order of 5% only. Even the frequency response is also very poor. It can work only over 500 to 5000 Hertz frequency range. And even the signal to noise ratio for this cone type of loudspeaker is about 30 decibel. This is about the cone type of loudspeaker. There is another class of loudspeaker, horn type of loudspeaker, that you have seen many times whenever there are certain public related announcements, etc. So in case of this horn type loudspeaker, instead of the radiating acoustic power directly to the listener area or to the air, the power is first delivered to the air trapped in a fixed non-vibrating flared horn. For example, like if the audio signals are here, these audio signals will first pushed towards this throat. At this point, these audio signals get back to this horn, and it is the horn that spread these audio signals to the sound listener's area or air. So that's why these horn type loudspeakers are also known as indirect radiator. So it is not this throat, this neck or this cone type or this throat area. It is not the throat area, but it is the horn area that push up all the audio signals to the listener's area. So due to this, the impedance matching is much more improved in case of horn type of loudspeaker as compared to the cone type of loudspeaker, and that's why the efficiency is also high in horn type of loudspeaker as compared to cone type of loudspeaker. The specialty of this loudspeaker is that it could act as a high pass filter. It acts as a high pass filter with a frequency range of 30 Hz to 10 kHz also. So because of this wide frequency range, this horn type of loudspeaker has a greater dynamic range as compared to the cone type of loudspeaker. So apart from this horn or cone type of loudspeaker, there is another one, another type, what we called it as the dome type of loudspeaker, wherein neither cone is used nor horn is used, but this acoustical energy is transferred to the air through this dome structure. So it is known as the dome type loudspeaker, whereas the diaphragms are of the shape of dome. As the sound is directly radiated from the domes, the directionality of this type of loudspeaker is much more better as compared to the directionality of cone or horn type of loudspeaker. The dome type of loudspeaker is classified into two categories depending on which material is used for the dome. It is like soft dome types or hard dome types, where in case of hard dome type, the aluminum or titanium is used for forming the diaphragm, or in case of soft dome type, the material like silk, cotton, these materials, lighter materials, are used for the construction or for the formation of diaphragm. So this is the classification of loudspeaker based upon its design. The third way by which we can classify loudspeaker into various categories is based on the classification based on the working principle of loudspeaker. As like in moving coil, in microphones, we have seen in microphones that there are various classes that depends on the working principle of that microphone. Loudspeakers are just same as the microphones, but it works exactly in reverse direction. Exactly in reverse direction. So, like in microphone, there are few classes. In loudspeaker also, like moving coil type of loudspeaker, electrodynamic loudspeaker, ribbon loudspeaker, plasma arc loudspeaker, or piezoelectric loudspeaker. What we have seen like crystal microphone, which uses a piezoelectric effect. Likewise, here also a loudspeaker is one of the category of loudspeaker that depends on this piezoelectric effect is the piezoelectric loudspeaker. So there are many other classes also that I haven't mentioned here, but these are the few very basic classes. Among these classes, we have to, as per our syllabus, we have to focus on the moving coil type of loudspeaker. Moving coil type of loudspeaker. So let us start. The moving coil type of loudspeaker is the most common and widely used loudspeaker type. It is also known as the dynamic loudspeaker. The working of moving coil type of loudspeaker is exactly opposite to that of the dynamic microphone, and it is based on the Faraday's law of electromagnetic induction. It is the general principle that the electric current produces a magnetic field, and conversely a changing magnetic field generates an electric current in a conductor. This principle is used in the working of this moving coil type of loudspeaker. So this is the usual diagram of such type of loudspeaker, moving coil type of loudspeaker. It consists of a cone. It consists of cone suspension. More important, it consists of a coil, wire through which current could be passed. What we called it as the moving coil, moving voice coil. Voice coil. These are the wounds over magnets. These are actually the two magnets, SN pole type of magnets that are separated. So this one is the permanent magnet. On one pole there is a wound of wire, what we called it as the voice coil. There is a lighter suspension of this voice coil over this support chassis, you can say. So in this bit, this is the construction of moving coil type of loudspeaker. But instead of that figure, I always like to follow this figure, the simplest figure, in which all components are very clearly shown. This one is the permanent magnet. So it consists of a permanent magnet. It consists of a frame or chassis to hold the whole unit. It consists of diaphragm, or what we call it as a cone. Also, this diaphragm is connected to the main frame through this undulations. These undulations. There is a dust cap to protect this voice coil from dust. These six number is nothing but the voice coil that has been wound over this permanent magnet, and this voice coil is suspended with the help of a spider, so that there should be a flexible movement of this voice coil over this magnet. So these spiders help such a free movement of this voice coil. So this is the simple picture of moving coil type of loudspeaker. Let us see one by one. The magnet, it provides the fixed magnetic field against which the field from voice coil operates. Field from voice coil operates. The magnet is typically made from ferrite or any powerful neodymium or other high-grade magnetic material. There is a frame that actually doesn't play any role in the transduction process, but it is the basic structure. It gives the basic structure to the loudspeaker. The diaphragm is the front part of the loudspeaker. It transfers the vibrations of moving coil to the air, as a result of which it presents a large surface area to vibrate, and thus it improves the sound. The diaphragm is made up of plastic, paper, or any lightweight material. Diaphragm undulations. These are the parts that enable the diaphragm to move freely and in a linear fashion with respect to the movement of voice coil. Dust cap, there is a dust cap. Main part, the moving coil. It is the key element of loudspeaker, moving coil. It takes the current from the audio amplifier. Suppose there is a microphone, it converts the sound I am speaking to the audio signals that will get amplified by some circuitry. This audio signal is then given as an input to the moving coil, what we call it as the voice coil. This current flowing through the coil generates a magnetic field which interacts with the magnetic field of permanent magnet, as a result of which a force is developed given by BLN, given by Biot-Savart's law. This force is perpendicular to the direction of current flow as well as the direction of magnetic field, which moves the coil. This force enables the coil to move, and hence the diaphragm to which it is mechanically attached, creating the sound waves. So this is the main function of moving coil. It takes the current from audio amplifier. The current flowing through this moving coil will generate magnetic field. That magnetic field will interact with the permanent magnetic field. The interaction between these two magnets generate some force which is perpendicular to the direction of current as well as magnetic field. This force will allow this moving coil to move back and forth to perform certain vibrations. These vibrations then get transferred to diaphragm, and diaphragm next it converts transfer this vibration to the air, and in this way this is the main part of moving coil type of transformer loudspeaker. This coil is supported by this spider, which allow a free movement of the moving coil. So these are the various parts of a moving coil type of loudspeaker. The main characteristic of moving coil type of loudspeakers are like it has a lower efficiency, as the acoustic energy is directly getting transferred to air without without a perfect matching of impedance. Due to this, there is a lower efficiency of audio signals. The signal to noise ratio is about 30 dB. The frequency response is limited to mid-range only. The distortion is about 10% and is non-linear because of the non-uniformity of magnetic field. The impedance varies from 2 to 25 ohm. So this is all about the moving coil type of loudspeaker. Thank you.